We are on page 35. We're continuing our study of quadratic equations. Quadratic equations have an exponent of 2. And you might remember when we graphed different kinds of equations way back in a prior unit, we had linear equations when we had an exponent of 1, x to the first power, or y to the first power, we had a straight line. You might remember when we had an exponent of 2, we had a graph that looked like this. And then we also, I think, did graphs of, whoa, I don't know why that's moving. We did graphs of cubic equations when we had a third, an x to the third, and it sort of looked like, if that's the coordinate plane, it kind of came down and went like that. So we're going to concentrate on graphing quadratic equations, and so we know that our shape is going to be a U-shaped, and we have a bunch of vocab that we need to talk about in this unit. So we're going to go through the vocab on this page, on 35, and then we'll actually start the graphing on page 36. So recalling the standard form of a quadratic equation, it's a function, and the standard form is the x squared term comes first with his coefficient, which is a, and then the x to the first term comes with his coefficient, which is b, and our constant is on the back end. The shape that we call this, most of y'all probably already know, this is a parabola. The parabola can open up like this one, or it can open down. Its vertex then, right here, is either a low point, like in this case, this is the lowest point on this graph. Every other point on the graph of this parabola is higher than the vertex, or it can be a high point if it opens down. And this is, the vertex is written in x, y format of an ordered pair, but just to complicate things, we usually don't refer to it as xy, we refer to it as hk, and I'll leave you hanging on that one. So this is called the vertex. It's the low point on this particular graph. It's represented by the ordered pair. Let's see, that's -1, looks like -4 on this particular graph. The next thing that you'll notice is on the vocab is the axis of symmetry. So this is a line, and in this case it's a vertical line that crosses through the vertex. So here's the vertex, and here comes the vertical line that crosses through the vertex. And generally, I don't know what you think of when you hear the word symmetrical, but when I hear something is symmetrical, I think of it as being even. So if you were to fold this parabola along the axis of symmetry, those lines would fold perfectly on top of each other. It cuts it into two perfectly congruent pieces. So in this case, it's a vertical line, that crosses through vertex. Next vocab word is concavity. Basically, it's saying, does it open up or down? So if it opens up, the concavity, if it looks like this, we would say the concavity is opening up. So it goes like that in a U shape. If the concavity opens down, it's an inverted U, like a big fire ant mound. That's concavity. And then let's run through, are there any more that we missed on that one? No. All right, this second graph example, we talk about x-intercepts. These are just like when we talked about linear equations. X-intercepts are the points and we'll talk about this again, but sometimes there's 2 points, sometimes there's 1, and sometimes there's none. So you don't have to have x-intercepts, but these are the points, if they're on your graph, where the parabola crosses the x-axis. Makes sense. Crosses the x-axis. So again, can be 0, 1, or 2 x-intercepts. Reminding you about the domain and the range. The domain are the possible x values for your graph. So on both of these graphs, it doesn't actually show an arrow, but it should. We should have arrows on both of these graphs to show that actually this graph goes on and on forever, and all of the x values on the x-axis are part of this graph ultimately. So on these two graphs, in this case, these two cases, all real numbers are is the domain. The range, of course, are the possible y values. And in this case, this graph to the right, the lowest y value is -4. So in this case, y is greater than or equal to -4. And in our case, our first case, what is that? That's also -4, right? Yeah. So on both of these graphs, the range is y is greater than or equal to -4. Okay, we'll stop there for a minute. I'll let you guys catch up. Let's see, we need to write these are the x-intercepts. So, again, we're going to use funkier variables R1 and 0 and R2 and 0. You don't have to worry about knowing that right now. So these are the possible points where the parabola crosses the x-axis, and then the y-intercept. This is where it crosses the y-axis, right there. We call that 0b. So you'll see these variables again in formulas, and so we're going to go ahead and start using them here, but for you to know, these just represent ordered pairs. Thanks for watching.